the title of this note is Derivatives of Exponential and Logarithmic Functions, and the outcome is to be able to use the formulas for derivatives of exponential and logarithmic functions. Okay, so there are 4 formulas here. We're going to start with the derivative of e to the x. So e is a special number, kind of like how pi is a special number. It's about equivalent to 2.72. So what is so special about e? One of the reasons e is really interesting is because it is the only function whose derivative is itself. So if the function equals e to the x, the derivative is also e to the x. You want to derive it again to get the second derivative? E to the x. The third derivative? E to the x. So that formula is really easy. The derivative of e to the x is e to the x. Remember, that's the notation d dx. The derivative of e to the x is e to the x. Now remember, all your rules about chain rule, product rule, quotient rule, those still apply. So what if you have a function that says e to the 2x? How do you take the derivative of that function? Well, the mama function, the outside function, is e raised to some power. The derivative of that function is itself. Remember, you keep the baby inside the mama. Then you're going to take the baby out and you're going to derive the baby. The derivative of 2x is 2. So we would write that like that. So the derivative of e to the 2x is 2e to the 2x. So the chain rule still works here. Okay, so next we have the derivative of a to the x. Kind of like e to the x, except the base can be anything. So the base could be 2 or 3. So how do you derive that? So we have a formula. If you want to take the derivative of a to the x power, it is going to be itself, kind of like e to the x, times the natural log of the base. I actually read this axlonol, and that's how I remember this formula. So it looks like e to the x, but then it's the natural log of the base. So if we want to take the derivative of y equals 2 to the x, just want that. We start by repeating it, and then we multiply it by the natural log of the base. Just like we saw with the e to the x, there can be chain rule. So what if we have 3 raised to the cosine x? So the parent function is 3 to some power. We derive that first. You keep it the same, and then you multiply that by the natural log of the base. So that's the mama function. Then you're going to take the baby out, and you're going to derive the baby. So that's negative sine x. So then you put it all together. Just clean it up all nice and neat. Negative sine x times the natural log of 3 times 3 cosine x. So there's 2 out of your 4 formulas. Those are all the exponential functions. Next, we're going to talk about logarithmic functions. So the first one is the natural log. Remember, that's when the base of the logarithm is e. So the derivative of the natural log of x is 1 over x. Now, the natural log of x, if you remember the graph of that, it has an asymptote at 0. That's a smooth curve. You can only put positive values in for x. So a lot of times what you'll see is something like y equals the natural log, and then there'll actually be an absolute value sign because you can only take the natural log of positive numbers. So the derivative of that would be 1 over x plus 1. Again, chain rule can happen. So what if you have the natural log of x squared? It would be 1 over x squared, and then you take the baby out, and derive the baby, times 2x. And then that can be simplified. It's 2x over x squared, and there's an x that cancels out. So it becomes 2 over x. All right, the last one we have is for any logarithm. So your formula here, this one's a little funky. Your logarithm is going to have a base, which we're going to keep calling a. Oh, that should be an a right there, not an x. So if you want to take the derivative of a logarithm, kind of like the natural log, it'll be 1 over x, but just like we had to do with the exponential functions, we have to multiply that by the natural log of the base. So let's look at a quick example. We have log base 3 of x. The derivative will be 1 over x times the natural log of 3. And again, chain rule can happen. What if we have log base 3 of cosine x? So it'll be 1 over cosine x times the natural log of 3 times, then you derive the baby. So then just cleaning that up. Okay, maybe this is multiple choice. I might even have the sine over cosine. I might convert to tangent. Either one of those answers is acceptable. So that is the end of these notes.